Review of the most popular materials for a private house. In January 2026, researchers from the Massachusetts Institute of Technology presented a report that forced the global architectural community to sink into deep reflection. According to this data, more than 80% of residential structures erected over the last 30 years may prove to be unfit for living in the coming decades due to fundamental miscalculations in the choice of materials. We are used to considering our home an unshakable fortress, but modern scientific debates continue around what exactly makes walls truly reliable. Old construction methods are facing challenges that are impossible to ignore in the conditions of a rapidly changing planet. Traditional ideas about comfort and safety are undergoing a serious reassessment by leading experts today. Recent evidence reveals that the concrete jungles and wooden frames familiar to us hide far more questions than answers. We stand on the threshold of an era where the choice of material for a private house ceases to be a matter of aesthetics or budget. Now it is a matter of survival in a world where stability has become a luxury and architecture is turning into a complex life support system. In this investigation, we will break down the main building elements through the prism of the latest discoveries and try to understand what we should invest our resources in. Concrete has long been considered the standard of strength, but in 2025, laboratories at the Massachusetts Institute of Technology published the results of testing a new type of self-healing composition. It turned out that ordinary Portland cement, which is used in most private houses, loses its structural properties much faster than previously assumed. Researchers discovered that microcracks begin to destroy the foundation of a house after only 15 years of operation under the influence of groundwater. This discovery calls into question the durability of millions of buildings around the world, forcing us to look for alternatives in the field of geopolymers. On the other hand, the Smithsonian Institution at the beginning of 2026 released an analytical review dedicated to the revival of ancient technologies using natural stone. Scientists point out that massive stone walls possess a unique thermal inertia that is impossible to recreate using modern synthetic insulation. A stone house with walls 3 feet, about 90 centimeters thick, is capable of maintaining a stable temperature inside the premises without the use of active cooling systems. This creates a completely different level of energy independence, which is becoming critically important in conditions of rising resource costs. There are two main scientific hypotheses regarding the future of heavy structures. The Harvard Graduate School of Design, in its 2024 report, asserts that the future belongs to hybrid materials, combining the strength of granite and the flexibility of polymers. At the same time, experts from Massachusetts insist on a complete transition to carbon-negative concrete, which absorbs carbon dioxide from the atmosphere during the hardening process. These discussions show that our choice between traditional brick and innovative blocks is now inextricably linked with global processes of environmental transformation. Wood has always been perceived as the coziest and most eco-friendly material. However, recent evidence reveals a dark side to mass wooden construction. A Harvard University study published in 2024 emphasizes the psychological aspect of living in wooden houses, calling it the Biophilia effect. However, the same scientists express concern regarding the chemical treatment of modern wood. A huge amount of flame retardants and antiseptics used to protect the frame at a distance of 20 miles, 32 kilometers, from the coastline creates a complex cocktail of fumes inside the premises. At the same time, in 2026, specialists from the Swiss Federal Institute of Technology in Zurich presented a technology for modified wood that exceeds steel in strength. This material retains all the advantages of natural wood, but is devoid of its main drawbacks, flammability and susceptibility to rot. Scientific debates continue around how much such interventions in the structure of the wood cell change its natural properties. We are faced with a paradox where the most natural raw material turns into a high-tech product of laboratory synthesis. Many homeowners choose glued laminated timber, believing it to be the pinnacle of engineering thought in wooden architecture. However, reports from independent environmental organizations for 2025 point to problems with the durability of adhesive joints under extreme temperature fluctuations. If your home is located in a zone where the temperature difference is more than 104 degrees Fahrenheit, about 40 degrees Celsius, the reliability of such structures may be called into question in the long term. This forces us to take a closer look at solid wood and forgotten log cutting techniques that were used for centuries. Brick remains a symbol of status and stability, but here too, unresolved issues force us to reconsider familiar views. In 2025, the National Oceanic and Atmospheric Administration published data on how increased humidity affects the porous structure of fired clay. It turned out that traditional hollow brick can act like a sponge, accumulating moisture and promoting the growth of microscopic fungi inside the walls. This not only destroys the structure, but also creates an invisible threat to the health of the house's inhabitants, which developers rarely mention. The Smithsonian Institution, in its recent study, proposed returning to the concept of warm ceramics using volcanic ash. This technology, borrowed from ancient Roman builders, allows for the creation of walls that literally breathe, providing natural air exchange without heat loss. Scientific circles are actively discussing the possibility of mass implementation of such blocks, which are capable of withstanding seismic loads of up to 9 points. This is especially relevant for regions that were previously considered seismically calm, but have changed their status in the last 2 years. It is important to understand that a brick house requires enormous energy expenditures at the stage of production and transportation of materials. In 2026, leading architectural firms began to implement a building life cycle assessment system, where ceramics often lose to lighter and more technological solutions. Nevertheless, the aesthetic value and sense of security provided by brickwork 2 feet, 60 centimeters wide continue to dominate the minds of private clients. We're observing a clash between the cold calculation of engineers and deeply rooted cultural codes. When we talk about materials, we often forget about what is between them. Insulation is the invisible skeleton of our comfort, and in this area, real upheavals are currently taking place. In 2025, scientists from the Massachusetts Institute of Technology developed a cellulose-based aerogel that has a thermal conductivity 5 times lower than that of air. This means that a wall only 4 inches, 10 centimeters, thick can replace massive brickwork in its thermal insulation properties. However, the cost of such technology currently remains out of reach for the mass consumer. Scientific debates also continue in the field of using recycled materials for insulation. The Harvard Graduate School of Design in 2024 presented a project for a house insulated with mushroom mycelium. This living insulation not only effectively retains heat, but is also capable of self-healing damage in the event of physical impact. Despite the fantastic nature of the idea, such houses are already beginning to appear within experimental settlements in Northern Europe. We see how the boundaries between biology and construction are beginning to blur, offering us completely different ways of interacting with space. There's also an alternative point of view presented by engineers from the Smithsonian Institution. They insist that the best insulation is the lack of need for it through proper building orientation and the use of natural airflows. In 2026, the return to the principles of passive design became the main trend in architecture. The use of simple materials, such as compressed straw or unbaked clay, suddenly proved to be a more effective solution than the use of expensive polymers.
This leaves us with a choice: to trust complex chemical compositions or to return to the wisdom of our ancestors, reinforced by modern calculations. Concluding our investigation, we must admit that the ideal material does not exist. Each of them is a compromise between price, durability, and the impact it has on our lives. We live in an era where information becomes the main tool of protection. Recent evidence reveals that those who blindly follow marketing slogans risk facing the need for a major overhaul of their dwelling in as little as 10 or 15 years. The true strength of a house today is measured not only by the hardness of the stone, but also by the flexibility of our thinking. I urge you toward intellectual autonomy. Do not take on faith the claims that concrete is eternal and wood is always eco-friendly. Study the reports of research institutes, such as the Massachusetts Institute of Technology or Harvard. Follow the publications of 2026 and ask uncomfortable questions to your contractors. Your home is not just a piece of real estate, it is a complex system that must protect you in a world of uncertainty. By choosing materials, you are choosing the scenario of your life for decades to come. Remember that the architecture of the future is not about shiny facades, but about the invisible connection between man and the environment. Scientific debates continue, and each new day brings us knowledge that can fundamentally change our understanding of proper construction. Be researchers, be skeptics, and build your home so that they can tell the story of your mindfulness to future generations. Your investigation is only beginning, and only you decide what the walls of your sanctuary will be.